Hello everyone. Alright, in this video we are going to look at 10 integrals and see whether they are improper integrals or not. And at the same time, if the integral is an improper integral, we are going to classify it as a type 1 or type 2 improper integral. Okay, so let's start. The first integral, is it an improper integral? Well, right in front of our eyes we can say negative infinity in the lower limit of the integral. So this is an improper integral, yes, and it's type 1. Okay, not types, type 1. All right, then let's look at the second integral. Again, right in front of our eyes there's infinity in the upper bound of the integral. It's very easy to categorize this as an improper integral. Yes, again it's type 1. Okay, so it's super easy to identify type 1 improper integrals. How about the third integral? What do you think? Now here in the upper limit or in the lower limit we don't see infinity or negative infinity. Okay, so certainly not type 1. Now we don't know whether this is an improper integral or not as well. So, okay, so let's see. The function we have is 1 over x minus 5. So 1 over x minus 5 is discontinuous when x is equal to 5. Right? There's an infinite discontinuity, a vertical asymptote. Now the 5 is a bad point and 5 is in fact the lower limit of the integral. So yes, this is an improper integral, okay, because the discontinuous point is in fact a point in the limit of the integral. So this is type 2. Right. Now let's look at the fourth integral. Now again, we don't see infinity in one of the limits, so not type 1 certainly. Now 1 over x plus 2 is bad when x is equal to negative 2. There's an infinite discontinuity. Now is negative 2 in the integral somewhere, in the limits? Well, the limits are negative 4 and 1. So negative 2 is not the lower limit or the upper limit. So is this an improper integral? Yes, this is an improper integral because negative 2, yes, negative 2 is not one of the limits, but it is in between negative 4 and 1. That's a problem. The discontinuous point, if the discontinuous point is in between the limit of the integral, then again this is type 2 improper integral. Okay, right, let's look at the fifth integral, 1 over x minus 6. We don't see infinity in one of the limits, so not type 1. Now 1 over x minus 6 is discontinuous when x is equal to 6, a bad point, 6. Now is 6 one of the limits? No, the limits are 0 and 4. Okay. How about in between limits? 6 is not in between the interval 0 to 6, 0 to 4, my bad. Right? So, is this an improper integral? Is this type 2? Nope, this is not an improper integral. Okay, this is a proper integral, nice integral. Okay, because yes, there's a discontinuity at x is equal to 6, but the integral skipped it. Okay, we are not integrating anywhere near x is equal to 6. Okay, great. Now let's go to some tricky stuff. Now tangent x. Okay, so tangent x. Now if you look at the limits, neither of them are infinity, so not type 1 for sure. So tangent x is actually what? Sine x divided by cosine x. Let's write it like that. Now you have a fraction here, right? The cosine x, the numerator, cosine x is 0 when what happens? Cosine x is 0 if x is equal to pi over 2, if x is 90, right? So 0 and pi over 8. So pi over 2 is neither 0 or pi over 8. So it's not in one of the limits. But is it in between the limits? Is pi over 2 is 90 between 0 and pi over 8? Well, pi over 8 is definitely less than 90 degrees, right? What is it? It's what? It's close to somewhere between 20 and 30 degrees, right? So, yeah. So, pi over 2 is not in between 0 and pi over 8. So this is a proper integral. Again, this tangent x is discontinuous when x is equal to pi over 2. So we want to see whether pi over 2 is in one of the limits or in between. So it's not the case. Alright, the seventh integral. Well, we know already tangent x is undefined when x is equal to pi over 2. Same as the previous integral. Now you can see pi over 2 is one of the limits, right? So this is an improper integral type 2. Okay, right. The previous integral was not an improper integral, but now it's a type 2 improper integral. All right, how about the 8th one? We already know that when x is equal to pi over 2, okay, again, the integral, the tangent x is undefined, discontinuous, and the pi over 2 is not certainly one of the limits, okay? Limits are pi over 4 and pi, but pi over 2 is in between pi over 4 and pi, right? I mean, pi over 2 is 90, pi over 4 is 45, and pi means 180. So 90 is definitely in between 45 and 180. So discontinuity is in between the limits. So this is a type 2 improper integral again. Okay? All right, so we have 2 left. Cotangent x. Okay, now pause the video and try to do it by yourself. Cotangent is, I'm going to write it as cosine x over sine x. Okay, that's the meaning of cotangent, right? Now, numerator, not the numerator, denominator, my bad. The denominator is 0, sine x is 0 if x is equal to 0, right? So, at x is equal to 0, the function cotangent x is discontinuous, okay, undefined. So 0 is a bad point, and it is in fact one of the limits. So type 2 improper integral. Okay, right, the last one. Again, when we know when x is equal to 0, cotangent x is discontinuous. Is 0 between pi over 4 and pi over 2? Well, certainly not, right? So this is a proper integral, not improper, okay? All right, so that's how you identify an improper integral. If you identify an improper integral, I taught you how to classify its type 1 or type 2. Okay, all right, now I think you have a good idea of figuring out improper integrals. In the next video, we are going to learn about convergence and divergence of improper integrals, and we will learn how to evaluate, how to solve improper integrals. So I'll catch you there. Thank you very much. Bye-bye.